Well, what a day. We've learned a lot today. Let's briefly recap and see where all of this might be going. To recap, today we learned about ImageNet Challenge and how instrumental it has been in driving progress in image recognition. And we've also looked at several of the large-scale ConvNet architectures that have contributed to this ever-increasing image recognition performance. And then we learned about transfer learning and discussed how we can capitalize on these large-scale ConvNets that people have developed and repurpose them for our own problems, including other tasks beyond image classification. And finally, we've learned about face recognition and some of the challenges associated with it. So in summary, large-scale CNNs and transfer learning based on ImageNet pre-training have been instrumental for the deep learning revolution after 2012. But what's next? There are two recent, very interesting developments that might change how we perform image recognition over the next couple of years. The first is going beyond ConvNets, vision transformers. Transformers are an attention-based architecture that has completely taken over natural language processing a few years ago. And transformers have also become increasingly popular in image recognition, and they've already performed at least on par with ConvNets. And transformers are really interesting because where ConvNets process information only locally using a convolution operation, transformers exchange information globally across the entire image using an attention mechanism. The second important recent development is going beyond supervised pre-training on ImageNet. We've learned that pre-training on image classification using ImageNet goes a very long way in learning strong visual representations for downstream tasks. However, this approach works well only if the images we care about are sufficiently similar to photographs from ImageNet, which is of course not the case for other domains such as medical imaging or remote sensing imagery. So there's clearly also a need to go beyond supervised pre-training on ImageNet. And this is where self-supervised learning comes in. It's called self-supervised because we don't hand annotate datasets, but instead we generate the labels for training from the data itself. One instance of such self-supervised learning techniques is contrastive learning, illustrated here on the right. It is very much similar to the approach we've seen for face recognition, except that it doesn't require labels. Instead, we generate two views from the same image by using different data augmentation methods such as cropping, scaling, changing color, etc. Then we embed these images using, for instance, a ConvNet into an abstract embedding space. And our learning objective is now to attract the embeddings of the same image while repelling the embeddings of different images. These self-supervised learning techniques have made a lot of progress in the last 2 years. And now they even outperform supervised pre-training on ImageNet for some transfer tasks like object detection. So to conclude, large-scale ConvNets and transfer learning based on ImageNet pre-training have really been instrumental for the deep learning revolution. And while that's still the standard approach, the paradigm may actually shift in the next couple of years towards transformers and self-supervised learning. So that concludes our day on modern ConvNets and transfer learning. I want to thank you all for joining, and I hope you'll have fun during the remainder of the Neuromatch Academy. Thank you and goodbye.